heat is the killer in the summertime, what's the killer in the wintertime?
More heat.
In a manner of speaking, yes. Carbon monoxide. So, and carbon monoxide is not exclusive to the wintertime, right?
Yeah.
It's just in the summertime we're more focused on air conditioning. But there's still carbon monoxide problems in the summertime too. Because you still got water heaters running, you still have stoves running, you still have vehicles running. Carbon monoxide gets into houses through all these different forms. Stoves, water heaters, furnaces, boilers, cars. I mean, there's a lot of different ways for carbon monoxide to get into a house. And I'm going to start this by asking you guys a question. Who in the trades do you think can best find carbon monoxide problems?
Nope.
Plumbers?
Nope.
What about carpenters?
Nope.
Then who?
Us.
Us. We as HVAC technicians are the single most important person that customer will ever have in their house. Because it is up to us to find those problems, prevent those problems, and fix those problems. If we do not take it seriously, and we walk into a customer's house, lackadaisical, goofing off, just saying, just here to clean your furnace, ma'am, and we overlook something as simple as gas pressures being set too high, that family can die. That's no joke. This is serious stuff, and our customers' lives are in our hands. So you guys really need to take this stuff seriously when we're in these houses. It is important that you guys are cognizant not only of what you are there to look at, but also the home as a whole. So when you're walking into these houses, you should have that CO monitor going. You should be checking everything out. You should be looking at how the flue pipes are set up for the water heater, the furnace. You should be mindful of the fact that they have a gas stove in their house. All of that stuff is important for what we do.
Did you know the highest producing CO level in the house is the stove? And
Yep.
it produces more CO than any other product in the house.
Now, we are not appliance repair technicians. So there is a realm where we do draw a line. But if you walk into a house and you see they have carbon monoxide present in the house, that is our responsibility. We have the most knowledge, the most training from NCI, and the best equipped tools to find the source of the CO and help the customer solve that problem. Because it is a problem. What CO level is acceptable in a house? Anything above 0 in a house is a fucking problem. There should not be CO sitting in a customer's house. And there are standards from ANSI and ASHRAE and shit like that that say, you can have 9 parts per million for 8 hours and be perfectly fine. There should be no CO in the house. Because, yeah, you can have 9 parts per million sitting in that house, and that's fine for a healthy, middle-aged adult. What about the newborn baby they just had 2 weeks ago? What about the 90-year-old grandmama that's sitting in the living room crocheting? Think she can handle all that CO every day? The answer is no. There should be no carbon monoxide in a house. If there is, there's a fucking problem. What percentage of people do you think don't know how carbon monoxide gets in a house? They did a study on like 1,000 people, and 55% of those 1,000 people asked had no idea what carbon monoxide even was. Now, what do you think, since Roy brought this up? We're coming into wintertime, right? What happens in wintertime? Power outages.
Snow, power outages.
Snow, power outages.
Backup generators, gas grills.
So people start using gas grills and backup generators because they don't have any power. If somebody has a generator and they've got an extension cord ran to it into the house through an open window and that generator's right outside that window, what do you think is going to happen? Where are those exhaust gases going to go from that generator? Right into the house. It is our job as professionals to make sure the customer has the knowledge to be able to appropriately set up and use those generators too. They need to understand how their house works. So if they've got an open window right next to a running generator, they're gonna put carbon monoxide in their house. So it is our job to make sure that our customers are safe. Not only is it our job, we are legally liable for that responsibility. According to ANSI Z21, any dangerous situation involving carbon monoxide is our responsibility as professionals in their home. If they hire us to come into their house to do a furnace maintenance, to do an air conditioner maintenance, to do a service call for their boiler, their water heater, their furnace, it doesn't matter. if we go into that house, knowingly or unknowingly, this is as the law is written, knowingly or unknowingly leave a dangerous situation with a piece of equipment producing carbon monoxide in their house, we are legally liable for those deaths. And not only is the company liable, you are liable. Not only if that family suffers a loss because of that, not only is Fixed Right getting taken to court, you are getting taken to court. You are losing your license. You are getting sued. So this is more than just our jobs. This is personal liability too. We have licenses and certifications for a reason. We need to make sure we are using them the way they are supposed to be used. So when you're in these houses, watching for CO, checking for CO, testing furnaces, you have got to take this seriously. And shifting gears a little bit to focus on the furnace side of things, which is what we are going to be focused most on in this wintertime. The most common causes of CO exposure in a house related to the furnaces are improper draft, overfired, meaning that it's producing too much heat. The ductwork, the exhaust can't handle it, so it's going to cause problems. Failed heat exchangers. And failed is a broad term. It's an umbrella term. Failed can mean a number of things. It can mean restricted heat exchanger. It can mean a heat exchanger with a hole in it, a crack in it. It could mean a heat exchanger that's rusted through. Failed is an umbrella term. Any type of heat exchanger failure creates a potentially dangerous situation for our customer. It's our job to find it, fix it if we can, or let them know that it's time to replace it. And on that topic, according to ANSI Z21, it is our job, our responsibility, and our liability to tag out, lock out a furnace if it is unsafe to use. On that side of things, what CO levels are acceptable in a flue pipe for a gas or oil burning appliance?
Under 100.
Under 100. Anything under 100 is acceptable in the flue pipe. What is acceptable in the house? 0. That's correct. At what CO levels do we tag out, lock out a furnace for exhaust levels of CO? According to ANSI Z21.
400.
400. Anything 400 or higher, that furnace has got
That
to
would be 400 air free.
Yes. It has to be air-free. Anything concerning ANSI Z21 is air-free numbers. So when you look at your CO, your combustion analyzer, there's two numbers. There's CO and there's CO air-free. CO air-free is the number we are worried about when it comes to ANSI standards. So that is the number you pay attention to on your analyzer when we're concerned with, am I locking this furnace out? So again, 400 or higher, that furnace cannot stay in operation. That is our responsibility to shut it down, lock it out, and according to ANSI Z21, if we lock out a furnace and decommission it, it has to be decommissioned in a way that requires the use of a tool to put it back in service. So you cannot just turn the shutoff valve and walk away from it. You're still liable. That customer turns that valve back on, it's your fault. Doesn't matter if you took pictures or not. You have got to use a tool to put it back in service. So that means take the wire, the W wire off the board, take the shutoff valve, close it, zip tie it, anything that requires the use of a tool to put it back in service. So just keep that in mind for when we have to shut these furnaces off. Technically, if you read, and this sheet is in your NCI book. I had Kelvin make copies of it because this is the sheet I want you guys to pay attention to the most. Take one, pass it around, please. According to the ANSI standards, any situation that is deemed worthy of shutting a furnace down is detailed right here. Violations include rising CO levels. So if you are sitting there and watching it rise steadily over the course of a minute, that is rising CO levels worth being shut down. Doesn't matter if it's 400 or not. If you can prove that the CO is steadily rising with pictures, video, what have you, that needs to be shut down. CO over 400 parts per million, like we just talked about. If it is over 400 parts per million and stable, it needs to be shut down. If it can't be repaired. If it can't be repaired. And that includes if the customer denies repairs. If they choose to deny the repair to get that CO down, it is our responsibility to shut it down before we leave. Are you out of the house and do not let you decommission it, you do not leave that site. You call the gas company. No bullshit. This is specified in the laws. If they throw you out of the house and do not want to repair it and do not let you shut it down, you cannot leave that house like that. You have got to call the gas company and let them know, hey, I'm at such and such address, I've experienced an unsafe condition in the house, carbon monoxide levels are over X amount, the customer would not let me shut the furnace down, I'm calling to pass this off to you to let you know there is an unsafe circumstance here, this family is in danger. Then you sit there and wait for the gas company. You do not leave until the gas company gets there. This is specified in the laws. Once the situation is handled and the danger is averted, then we can leave. Circling back to what's worth tagging out, locking out furnaces.
Everything.
We talked about the CO over 400 and stable. We talked about CO rising. CO over 200 parts per million is regards to water heaters. Water heaters have a different standard than furnaces do. That is also detailed in your book. Don't know how much we're going to mess with water heaters, but if we have to get into it, that's our responsibility, guys. If CO levels are high, we got to do our diligence. So again, CO over 200 for water heaters. Delayed ignition, excessive flame rollout. So if you have a gas valve that's leaking and it's causing that propane or that oil, if it's an oil pump, to puddle in there, and then when it lights, you get a big boom, flame shoots out. If it's a gas furnace, that's a problem. If they're not willing to fix it, it's got to be shut down. It's a safety thing, guys. You think flames shooting out of a burner is safe? No, not at all. Not only is it not safe for the simple fact of the carbon monoxide and the exhaust gases it's puffing out, it's also not safe because it can set things on fire. Fuel leaks. So again, fuel leaks, if they're not willing to fix a fuel leak, that is a potentially dangerous situation. According to NCC 21, we can shut it down. Fire hazards, so anything that poses a fire hazard. So for example, if they're using single wall pipe on a gas-fired appliance and it's running up through the second floor and it's got carpet on the second floor or it's got that wood floor right around it hugging it, that's a fire hazard. And this is, these next two are the most important things that we run into on a daily basis. Cracked heat exchangers, CO does not need to be present. That's important. If you guys do an evaluation and find a hole in the heat exchanger, it does not matter if there is carbon monoxide present in the ductwork or not. That heat exchanger has an opening to the air in the house, needs to be shut down. Take a picture, take a video, whatever, document it, show the customer an unacceptable flue installation or deterioration. So how many of you guys that have worked on oil furnaces have walked up to an oil furnace and poked the chimney and your finger went right through it?
Just ran that.
That's a problem. That is a problem worth shutting it down if they don't want to fix it. Because exhaust gases can get into the house. That's why. Doesn't matter if it's happening. It does not matter if that is what is happening. It's a chance it can happen. If we walk away from it and leave it, that's our fault. If we're doing these lockout tagouts, you got to shut it down in a way that requires a tool to put it back into service. So that's the first step, right? The second step is you got to make sure we're communicating this to the customer. It is not something you can just do. You have to actually have the conversation with the customer, tell them what's going on, and again, if it is a situation that is repairable, we have to offer the repair before you shut it down. Have a conversation with the customer, let them know, ma'am, your gas pressures are set too high, it's causing excessive carbon monoxide in the exhaust, I can fix that. The cost for me to fix that is going to be this much money. Just to let you know, after I address this problem, I'm going to do another evaluation and make sure there's no more problems for you. So you have to have those conversations. If the customer's like, nah, I'm good. Okay, ma'am, well, I just want you to understand that legally, if we don't make any repairs on this, I have to turn this off. It's a safety concern. I'm not trying to scare you. I'm just letting you know I can't let this thing run unsafe for you and your family. So if they don't want to repair it, that's fine, but you got to do something. We can't just leave high levels of carbon monoxide. When we have those conversations, if it does result in us having to shut the furnace down, you got to do the decommissioning in a manner that requires a tool to turn it back on. You have to leave a red tag. The law states there's supposed to be 3 copies of this. 1 copy is attached to the equipment. Take a picture of that. 1 is handed to the customer, so that way they have a copy in their physical possession that says, my equipment was shut down because it's unsafe to run. The 3rd copy goes to the office to be added to their file. Got to make sure that we document it. Documentation and communication are some of the most important things in our trade, especially now so in today's I'm going to sue you society. So covering our ass is the most important thing we can do, right behind being safe. So again, 1 tag on the furnace, 1 tag to the customer, pictures of the tag that's on the equipment. Questions on that? I'm going to touch briefly on the draft and overfire stuff. So what is the draft supposed to be on an oil furnace? Negative 0.02. That's the standard. There's a range. Obviously, it doesn't have to be perfect. It doesn't have to be negative 0.02 constantly. It can be negative 0.02 to negative 0.03, negative 0.01. It has to be around that negative 0.02. If you go above negative 0.034 and you're at negative 0.067, you are drafting too much. Draft exceeds that negative 0.04 and you start getting up to 5, 6, 7, you're drafting too much. What that means is the flue gases are moving through the heat exchanger too fast. Things that can result because of that, really high flue temperatures. You are essentially sucking the flame out of the heat exchanger. So you're going to start overheating the furnace and the heat exchanger. The ways to fix that, draft regulator. Draft regulators calm the draft down. You're letting it regulate better. So with draft regulators, they have the faceplate with a weight on the back of them. You stick your combustion analyzer, your draft gauge in the flue. You make an adjustment to the weight, move it one way or the other, see how it affects it, and see where your draft ends up. It's trial and error. But you got to make sure the draft is set correctly. If you're drafting too much, that's a problem. You're going to have high exhaust temperatures. It's not going to run right. The exhaust gases are not going to stay in the heat exchanger long enough to give their heat to the air. So that can result in low delta T's. So you're not heating the air up in the house that much, or as much as you should be. If you control the draft, you control the way the burner runs. And that's true, because the exhaust gases are designed to stay in that heat exchanger for a certain amount of time. It's called residence time. There's a certain residence time that these boilers and furnaces are designed for these exhaust gases in order to properly give heat to the water or air that's moving through the heat exchangers. If you are moving the exhaust gases out of the equipment too fast because you have too much draft, that's just as big of a problem as not having enough draft. The draft regulators are the best way to fix that. You just have to make sure they're set properly. And that is part of our tune-ups, is making sure the draft is set correctly. So when you're there doing your combustion analysis on this stuff, you got to pay attention to the draft. Because if your draft isn't right, your readings are going to be off anyway. The other side of that is not having enough draft. So if your draft falls down to that negative 0.10 area, that means you're not drafting. So that is a much bigger problem than having too much draft. It's still a problem, but this one is a safety problem. If you're not drafting, where do you think the exhaust gases are going to go? In the space. So now at this point you have what's known as spillage. You have carbon monoxide spilling out of the exhaust, out of the equipment into the house. And it's going to start to puddle at the equipment and spread throughout the house. So when we don't have enough draft, that is when our real safety concerns start. Because at that point, we are not moving the exhaust gases out of the chimney at all, so the exhaust gases are going to go into the house instead. The proper ways to address that is, first and foremost, you got to make sure your chimney's clear. You got to make sure the exhaust gases have a path out. The lack of combustion air is a big, big problem for modern gas furnaces, induced draft gas furnaces. So when you walk up on an induced draft gas furnace, 90%, or 80% for that matter, you have got to pull combustion air, an ample amount of combustion air from somewhere. So if it's in a closet and it doesn't have a dedicated pipe for intake air, where are we pulling combustion air from? The space. If it's in a closet with a solid wood door and that door is shut, do you think that furnace is getting enough air to... No.
You need some louvers.
You got to put a louvered door on, you got to put a flat air, or a flat pass-through grill. You got to do something to get air to that furnace so that way it can do what it's supposed to do and light off. A lot of houses do have all of the gas burning appliances in that same mechanical room. Like Bowie is a prime example of that. In those Levitt homes, you got the water heater right next to the furnace in most cases. So you got to make sure you have proper combustion air, proper air exchanges into that room where the equipment is. Performance is the same thing as HVAC.
Yep.
We have got to look at everything in the home as a whole, not just the pieces that we're there for. Everything that we do affects everything in that house. So adding a return, that's changing the way the air moves throughout the house. We've got to think about where we're adding returns. We've got to think about how that's going to affect the system as a whole. Adding a return in a basement, if there's not enough supplies dumping into that basement to compensate for that return that it's pulling, the air that it's pulling out of that basement, you're pulling the basement into a negative. You're going to start pulling in outside air and outside humidity into the house. Question on the return stuff. Let's say you guys got an oil furnace in the basement, right? And we had a return right next to that oil furnace in the basement because the ductwork's undersized. Your draft damper's right there at the oil furnace, right? What happens when your supply fan kicks on and starts pulling return into the basement? Where's your exhaust gases going to go? Right out that barometric and into the return. What's going to happen to that family of 4 that's in that house? At that point, this is just compounding issues. You really have got to pay attention to the way the house performs as a whole. Let's talk quickly about CO levels and actions that correspond to them. So we already discussed that CO levels in a house should be 0, right?
Yes.
Shouldn't have any. What happens if your CO, let me rephrase this differently. What CO levels in the house should you start to evacuate the house? According to ANSI Standard 70, if you have 70 parts per million in the house, that family needs to be evacuated and they need to go to the hospital. As well, standard 2034 CO detectors that you buy from the store cannot make a single noise unless they are reading 70, shut up, I'll get to it, 70 parts per million for 4 hours. The exception to that is if they're reading 35 parts per million for 30 days. And if it drops below 35 to 34, it resets the timer. Standard CO detectors have a ridiculously high threshold before they will go off. Low-level monitors have a readout that will let you know anything above 5 parts per million will display on it. That is a big difference of 5 parts per million to 69 parts per million for 3 or indefinitely. All of these standards are made with a healthy middle-aged adult being used as the reference point, for the record. So if there's a newborn, if there's a toddler, if there's a 95-year-old grandmama in the house,
0 tolerance.
they can't handle the same levels of CO, usually, that a middle-aged adult can. So that 69 parts per million indefinitely in the house can kill that baby.
Yep.
Middle-aged adult be fine, in theory, according to their standards. But that's the difference between the standard UL 2034 CO detectors that are sold in stores and a low-level monitor. And that's why recommending a low-level monitor is better than having those standard ones that you buy from the store. Now, we can't just sell them unless we know what to do at those readings, though. William, what CO levels in the house do we start to ventilate the house?
35.
35 or higher. That's the number you're thinking of. So according to ANSI standards, any CO levels above 35, the house must be ventilated to below 35. Ventilate the house involves opening windows, putting fans in windows, opening doors. They don't have to leave the house. They probably should, but they don't have to. At 70 and higher, they have got to get out. So if you walk into a house and you're reading 70 or higher on your monitor, guys, let's go ahead and get outside. Now, I don't want to alarm you, but there's carbon monoxide in your house and it's unsafe levels. And they should go to the hospital at that point. So we got to know what to do when these CO situations arise. And that's kind of the point that I wanted to get at with today's training is we've got the knowledge, we've got certifications. Do we have this stuff in the forefront of our minds to be able to know what to do in all these situations that we're going to come across?
So apart from the detector, right? How do you protect yourself otherwise?
You got to have that going,
Yeah.
and if those levels are excessive, technically, according to government standards, anything above 30 parts per million, the fire department is supposed to be wearing their scuba gear in the house.
Oh, that's what
They're
that's-
rebreathers.
So,
If the fire department is supposed to be wearing their scuba gear at 30 parts per million, why the f*** in the house at 70?
that's what I'm saying.
So no, I don't want anybody to put their lives in danger. So if you go into a house and there are elevated CO levels, I mean, even at 30 parts per million, I'm uncomfortable. I'm not staying in that house. So yes, at that point, we get people moving out of the house. This is our personal plan of attack. At 30 parts per million, let's get people moving out of the house. Let's make a call to the fire department. Let's have them come in, do their thing, shut off the gas or whatever they got to do. And once that situation is safe for us to come in and take a look at the equipment, then we go in. I'm not asking any one of you guys to put your life in danger. I want to reiterate that. Do not stay in an unsafe situation. I do not care about the laws. I'm letting you guys know legally what we're supposed to be doing. But on a personal standpoint and a company standpoint, I don't want any one of you guys to get hurt. Not a single one of you. I want you guys to be safe. I want our customers to be safe. So if we walk into a situation where there's over 30 parts per million, pump the brakes, start moving people out of the house and just let them know, hey, there's some high levels of carbon monoxide in the house. Before I start looking at the equipment, I would like to get the fire department out here to do their check, shut the equipment off, and then I can go in once the CO levels come down, and we can see what's going on. Because we cannot do our job if we're laying dead on the ground. We can't go home to our families if we're laying there dead on the ground. And that's what's most important, is I want every single one of us in here to go home at the end of the day in the same shape or better than we came into work. While you are in there, you need to have that CO monitor going. It's not just something you walk in, all right, looks good, turn it off. Keep it on, keep checking it. The whole time you're running that furnace, the whole time you're working, that thing should be somewhere you can look at it and check on how things are doing. Especially if you walk into a house that has CO. If you walk into a house and you see it's got CO, that right there should heighten all of your senses to where you're checking that thing by the second. Because that situation can change like that. Oh, I'm below 30, I'm good. Go down to the furnace, you walk up to the furnace, that 30 shoots up to 150. You're unconscious in minutes. Not good, not a good situation. You need to be watching, paying attention, be mindful of what you guys are working on, where you're working at, the situation, what's going on in the house. If customers making breakfast, be mindful of that. You're running the furnace, they got their kitchen exhaust fan going because they're cooking breakfast for their family. Watch how that affects your CO. Because to Neil's point, if they got a big ass kitchen fan, when they flip that thing on to vent those the fumes out from them cooking, that could start pulling exhaust gases back in on you. You're at the furnace working, you don't know what they're doing upstairs. They could kill you and not even know.
I have real life experience with this and everything. Okay, they'll put this gas furnace in, and they never put a bottom in the furnace. And so what happens is, when that furnace vented out, it went up this chimney, the furnace came on, and the other crock was sitting wide open, and it come back down the chimney. Channel 4 News was down there. Everybody that was church went to the hospital and everything, and they didn't call us up and everything to figure out what the problem was. And that's when we found the whole bottom of the furnace was sitting open. Trane makes furnaces that sit open on the bottom, and you're supposed to, patch them with sheet metal before you set them, and people don't. They just set them on concrete so you can see them. If you have furnaces that are sitting open on the bottom, you will have that negative pressure. If you have flues that are just sitting wide open, okay?
Circling back to what Jake was asking with the CO levels exceeding 100 parts per million in the house, same process as if it was above 70. Evacuate the building. You need to make a phone call to the gas company or the fire department. That family needs to go to the hospital. They need to get checked out, regardless if they're feeling bad or not. They need to get checked out. It's a silent killer for a reason. They might not be showing symptoms right now. They could be dead later. Once it's in your blood, it's in your blood. You got to get it out. We don't have the tools and the knowledge to get it out of them, so they need to go to somewhere that will help them. So if the CO does exceed 100, it's the same principle as if it's above 70. This is a very serious topic, and it's why I wanted to cover it first with us going into heating season. This stuff is around year round. It's not just exclusive to heating season. Carbon monoxide is something we should be mindful of year round. But I know that as summertime gets in its swing, most of the time, most of us are just like, all right, got to get up in this attic, get this knocked out real quick, on to the next. The carbon monoxide will kill you, regardless of time, day, year, doesn't matter.
It's on site with carbon monoxide.
So we need to be mindful of this stuff, and I'm going to reiterate what I started this with. We are the single most important person that family will have in their house. And that is not an exaggeration, that is a fact. Electricians, plumbers, carpenters, roofers, they do not know what we know. They do not have the tools to find what we can find. They can't help that family the way we can. It's our job as professionals, both legally and personally, to make sure that we are leaving these customers with a safe, healthy home that they can enjoy their family with. Does that make sense?